Welcome, Precalculus students. This is your second lesson on dot products. This one is specifically about dot product and angles between the two vectors. So here I have two situations. I have two vectors, v and w, and the angle between those two vectors is an acute angle, meaning it's less than 90 degrees. I have two other vectors, vector t and vector u, and the angle between them is greater than 90 degrees, and so it is obtuse. You'll never have an angle that is greater than 180 degrees because never greater than 180 degrees because you always find the angle that is less than 180 degrees to talk about as the angle between the two vectors. The question is, I've got this angle between these, this theta that's acute, this beta that's obtuse, and what's going to happen with the dot product? So let's look at this first situation, v and w, where we've got an acute angle. When we look at the dot product, the dot product of v and w will always be positive. And the question is why? Why is it always going to be positive when we're talking about this specific case where it's an acute angle between them? And it's because, one, magnitudes are always positive. Magnitudes, you're taking the square root of two things, you square, so it's always going to be a positive answer. Magnitudes are always positive. It's a distance, if we think about it graphically. And the cosine of any acute angle, meaning an angle between 0 and 90 degrees, meaning an angle that you could think of that's in the first quadrant. It isn't that it's situated in the first quadrant, but it is in that same realm of degrees, 0 to 90 degrees. It's always going to be positive. And the dot product is a magnitude times cosine of some angle that's less than 90 degrees. So you're going to have a positive times a positive times a positive, which is always positive. So therefore, whenever you're going to take the dot product of two vectors that have an acute angle, you're going to get a positive result. But let's look at the other situation. The other situation here where we've got vectors t and u, and this time I'm going to look at the dot product of t and u. And the dot product of t and u is going to be negative. And the question is, why is that going to happen? Well, in this case, the same thing. We have magnitudes that are always positive, and you're going to be multiplying those together, and you're going to have a cosine of an obtuse angle, some angle that's between 90 and 180 degrees. Well, that's similar to all of those angles that are in quadrant 2, and in quadrant 2, cosine is negative. So any angle that is between 90 and 180 degrees is going to have a negative cosine. So when you do the dot product, you're going to get a positive times a positive, the magnitudes, times a negative, which means you're going to get a negative. So that was looking at the situation of acute versus obtuse angles between two vectors. The dot product will always be positive in this case. This case where we've got an angle that's obtuse, the dot product will always be negative. Let's look at one more situation, and that is that of orthogonal. And the word orthogonal has to do with right angles, things that meet 90 degrees or are perpendicular to one another. So here's two vectors, p and r are perpendicular. I've got the marking there. They're perpendicular to each other. So I can say that vectors p and r are perpendicular. I have two other vectors here. I have s and t, and the angle between s and t is 90 degrees, which also means perpendicular. We can say 90 degrees, we can say perpendicular, we can say just right, they're right angles. But in vectors, we typically call that, we just say, oh, they are orthogonal vectors. Well, the question becomes, how does this situation, having an angle that's 90 degrees, how does this affect the dot product? Well, this is what we're doing again. We're saying, okay, we've got, when we had p and r, I should have marked on here that they are perpendicular to one another. So these ones were perpendicular. And we can see that here, that cosine of 90 degrees. The magnitude of p is positive, the magnitude of r is positive, and the cosine of 90 degrees is 0. Well, it doesn't matter what the magnitudes are, that when you multiply those together, you're going to get 0. So the dot product of these two perpendicular vectors, or these orthogonal vectors, is 0. S and T were also perpendicular, so they had 90 degrees. And once again, their dot product is going to equal 0, which gives us our final statement about orthogonal vectors, and that is the dot product of orthogonal vectors is 0 always. But since that's the case, we have something else, and that is the converse of it, which means if we know the dot product is 0, if the dot product is 0, then we know that the two vectors are perpendicular, so we can state this in reverse. It's not just that if we know they're perpendicular, the dot product is 0, but we also have if the dot product is 0, we know they are perpendicular. So we can say this. This is a rule that anytime you do the dot product and you get 0, you have perpendicular. And this is called biconditional. Means it goes either way. If they're perpendicular, I know the dot product is 0. If the dot product is 0, then they are perpendicular. We also had earlier, when the dot product is greater than 0, then the angle between them, I'm using theta to refer to the angle between them, must be less than 90 degrees, otherwise known as acute. Okay, and again, this is biconditional. If I have an angle that's less than 90 degrees, the dot product will be positive. If their dot product is positive, then the angle between them is less than 90 degrees, or they are acute vectors. And our last one of biconditional is when they are obtuse. When the angle between is greater than 90 degrees, meaning obtuse, then the dot product is going to be negative. The dot product is less than 0, so it means negative. And this again is biconditional, meaning it doesn't matter whether you start with the angles and you can talk about the dot product, or you have the dot product and you can say that the angles are obtuse. Okay, and I just want to remind you that theta is always less than or equal to 180 degrees, because we would never have, and I'm going to just show you real quick, if I have these two vectors and you have a vector here, and you said, well, I'm going to go all the way around this way, more than 190 degrees, I'm going to come down here, and I'm going to say, here's my other vector. This is the angle between them. This is not the angle between. The angle between is always the angle that is less than. So this theta is less than or equal to 180 degrees. Okay, so that was your second lesson on dot product that had to do with orthogonal, acute, and obtuse angles between them.